Welcome everyone. Thanks for joining this afternoon. I don't know about anyone else, but I had lunch about 20 minutes ago. Try to keep you awake, try to keep yourself awake. Won't be death by PowerPoint. Hopefully we can have some good interactive dialogue. Obviously, PowerPoint will be a tool I'll use a little bit, but again, feel free, ask questions, interact. I'll ask you some questions. But my name's Brandon Bollig. I'm a regional sales manager with Yaskawa Motive and Robotics Division. Yaskawa is a global motors and drives manufacturer and a great way to package a lot of motors and drives. It's in a robot controller or in a robot mechanical unit. Personally been in the robotics industry for about 20 years. Started out as a technician, application engineer for an integrator. Went to work for Yaskawa in 2011. Left for a little bit, worked for another integrator, and now I'm back. Again, welcome and thanks for joining here today. Agenda for the conversation. I'm going to focus a lot on collaborative applications, or what I would call collaborative applications, not specifically cobots or power and force limited robots. So a lot of the presentation material is based around our HC series human collaborative, but a lot of my dialogue is going to be back and forth on both. We'll just talk very briefly about some of the current market trends. We'll talk about applications, what makes a collaborative application. I'll give some examples. If we get all the way through, I can do a little bit on our HC series, but I really would like to have good dialogue and not do a sales pitch up here. We can do that out there later if somebody wants to know more on that front. So we talk about the collaborative robot market as a whole. 1996 was the first introduction to a power and force limited collaborative robot. Two gentlemen developed that. 2004 to 2008 was kind of a long release period for some of the first, into the market. And then obviously the expansion to where we are today. You see Omni out here, and everybody here's any involvement in the automation space, you're going to hear cobots or collaborative robots. Question there. Who in here is anybody have cobots in their facility or power and force limited robots? Industrial robots? Okay. You guys have both. So from a market perspective and industry acceptance, it's truly everywhere now. Power and force limited robots have been put into every application pretty much you can think of. A matter of opinion whether it's correctly applied or not, but if they're doing the job, I guess why not, right? We'll talk a little bit about, I'll inject a little of my opinion, try to be non-biased, but you'll hear a little of that today. I'll just leave this slide at this. So again, I hit on, they're really in every industry. You've got them welding, you've got them doing assembly, you've got them doing packaging, palletizing, machine tending, you name it. I guess maybe a question for the group. Does anybody have input on why? Maybe you guys have both. What drives cobot versus industrial robot, and what do you think the entree is? So if you need to run a certain speed, you're going to bump up to an industrial arm, but if you don't have to, you're collaborative. Okay. That's very common, certainly not wrong. I personally think that why they've been accepted in the market is more ease of use. Like it broke down cobots, and probably don't want to give them too much credit here because they're not here, but ultimately I'll say it. I mean, UR broke down a lot of barriers with their marketing and the ease of use when they first came to market. That's really what drove a lot of it. So it was no longer the applications engineer saying, I can use a robot to do this task and it can save us this much money. It was now the C-suite level, ownership group, executive level that's coming back saying, this isn't so difficult because they touched a pendant at a trade show or something like that. And now it's being driven down from the top. And in my opinion, that also helped with the development of more ease of use through tools. All the different manufacturers from end of arm tooling to vision to IO, they now have developed these interfaces that are plug and play or very close to plug and play, which has helped the entire robot industry, not just cobots. So it's really driven kind of a cultural shift in the market in automation in general. Talk a little bit about what does it mean to be collaborative. So really there's three different means of collaborative applications. You're either in coexistence with the robot, which means you essentially have some separate spaces, but there may be an opportunity or a time where you're going to interact with that robot. So we consider that coexistence. Cooperation, where you may be directly interfacing on a more frequent level. And then true collaboration, you're in the robot space all the time, the entire time on the application. So maybe another question, like, can you do cooperation with an industrial robot? How about if you have a safety guy and you've got some area scanners or light curtains added in? We'll save that for a little bit later because I want to talk on that a little bit further. But I think that is definitely the perception. I'll challenge that in a bit. But yeah, realistically, you can do coexistence and cooperation with an industrial robot with the addition of some safety technology, an area scanner, a light curtain. I've got some slides on the bottom of this. There's new companies emerging daily that are releasing products for 3D vision for safety that's being approved by the ISO and the TÜV and all the safety standards. So there are tools and technologies out there. But if you want to do true collaboration, always in the space with the robot, and you're not handling razor blades or lawnmower blades or a grinder, power and force limiting robots are what everybody knows is the cobot. Questions?
A collaboration thing where somebody using a grinder and the collaborative robot was turning the parts so that they didn't have to pass so much muscle strain.
I can actually see that as a fairly good application. Yeah, because the operator is handling the dangerous portion of the application, right? As long as the part wasn't full of sharp edges and stuff like that.
Well, they were wearing.
Okay.
Hit the top edge, step on the pedal, or the button ring together. And next hit, step on a pedal, or look for another head. It was that application of stuff.
We see
Cool.
interesting stuff like that all the time. And those are the applications that are continuing to kind of broaden the spectrum of just automation in general, right? It doesn't matter if it's a cobot or an industrial, it's opening the eyes to what else can be done with a robot. I guess I don't need to use my laptop. So a true collaborative robot is equipped with safety functions. So our particular robot, which what I'll speak to the most, we combine a couple of things. We have what we call functional safety, which is a software safety tool. It's safety logic built into the robot controller that allows us to define interactive space, where the arm can work, what speeds the arm works, depending on what safety signals are coming into the robot controller. And then in addition to that, there are dual redundant sensors on every axis that are monitoring force and torque. So we can set that power and force limiting based on the application. So there's no one number of speed or force. Every application needs to be looked at through the lens of what is safe. And if anybody's read the RIA standards, it's fairly gray. There's a lot of wiggle room. There's a lot of opportunity for the end user to interpret things a certain way or incorporate work instructions and peripheral safety equipment like safety glasses, shoes, whatever, things to incorporate additional levels of safety, and then it allows you to kind of work around some gray areas. But obviously it's up to every end user to do a risk assessment. Even if an integrator supplies you with a solution, there is a portion of that risk assessment that's required. Whether it's done all the time or not is, I think, going to be a work in progress, but the end user should incorporate risk assessment into work instructions. So I talked about the functional safety unit, and I talked about power and force limiting, which are the sensors, but there's also the hand guiding. I have my opinion on that. We've had hand guiding in industrial robots for many, many years. ABB had it, Yaskawa had it. You can incorporate a 6-axis force torque sensor on almost any robot and incorporate hand guiding. Whether it's a value or not is up to the individual, in my opinion. I've had many customers that have spent the extra money for hand guiding, and then hand guiding, all it means is you're going to grab the tool and you're going to drag the robot around and teach points by dragging it instead of holding onto the teach pendant or using an offline programming software or something like that. But that is, hand guiding is a part of being a collaborative robot. Oops. So I talked about the functional safety unit. As I mentioned, there's it allows you to set up logic, and it looks just like ladder, like program ladder logic, any other software where you're doing incorporating bits and bytes and IO to make a decision determination of what you want to do next. We do the same thing with safety. So I want to go back to that perception of low cost. So I know what roughly, right, what TM sells for. I know roughly what UR sells for. I know what our HC products sell for. And I've done the study and the comparison multiple times. And I know where I can sell our GP or general purpose series robots. And my GP series is significantly lower cost than my HC series. So to buy an industrial robot that has full industrial capabilities and then incorporating some safety technology, area scanners, light curtains, whatever the case may be, there's a lot of times where you could be same or even lower price potentially than a power and force limited robot, because that's got the additional sensors and devices built into the arm. Yeah. Yeah. So that's one other thing I'll do a pitch a little bit. Like if you truly do a side-by-side comparison, we were not first to the market with power and force limited robots. But I'm confident in saying we have the most robust. There's not another power and force limited robot in the market that's built as well as our HC series. So I'll keep that pitch relatively short, but from an IP67, smooth surface, castings, real motors, drives, it's built exactly like our industrial robot, with the exception of the appearance and the smoothness. There's more time and energy put into that because that is also a part of the risk assessment. Sharp edges on those arms are a bad deal. So if you are considering a power and force limited robot, take a look at the HC10 out there. It's a real deal. It's a great product. Proud to offer that. So did anyone walk by the little GP4 picking up it's the blue robot right around the corner, picking up the little PVC fittings? See that one? So I don't know if you noticed when you walked by, if you were too close, it maybe either slowed down or stopped on its own. Basically, all we're doing is speed and space separation. So we have the ability to leverage that area scanner that's mounted on the table and define some spaces based on how fast Chad or whatever apps engineer programmed that. We can then set the safe distance for a person to get up to it. So as you approach, the robot will begin to, it will slow down. It'll continue its task, keep doing its work at a slower. As you get right up to it, it will stop. It's not an e-stop, but it is a controlled safe stop. So we have the ability to do what's called stop state monitoring. So historically, just say 15 years ago, you got that close to a robot, you broke a light curtain, it would go into an e-stop condition. It would drop all servo power, it would drop all pneumatic power, whatever the case may be. You'd have to go over, reset, fire everything back up, potentially lose your place in the program, try to recover from it. Now with stop state monitoring and the ability to leverage the functional safety unit, we can just hold the robot, no faults, no emergencies. And as soon as you back out of that space, then that robot starts moving again. It's great for machine tending applications, palletizing, pick and place on maybe a moving line type scenario where someone has to go grab something. They don't want to stop the robot. They don't want to stop the line. They don't want to stop everything. But if they go in there, do what they have to do, and then it takes right back off. Questions on any of that? So how do we test to prove that it's safe?
Right. There's some kind of.
Yeah, so from the standpoint of it truly being stop state monitoring, that's done from the factory box.
Okay.
So that takes care of the real up close experience, right? The robot's working here around here now, it has to stop. But there's really no subjectivity to that. It is what it is. You get close to stop. Where that comes in is how far away you have to stop it. And that is calculations that is purely based on, well, I said purely, I have a hard time using that word. But it's either max speed of the robot or programs. So you can go in a controller and through variables, limit what the max speed of that on is. So you take that speed, and then there's a table of speed stopping distance. So time it takes for that arm to be moving at, let's say it's moving at 100%, right? But it takes 3 milliseconds, whatever the number is. But there's a calculation of can a person get to a valid cylinder? And literally to the extent really following, you're supposed to almost be wrong. Like you don't go, well, it's stopped and you don't get it, it's still conversion. So there is a true calculation, and it also incorporates the scan time of the system. So if you have an area scanner, not every area scanner is exactly the same. Some of them have been the same. Light fragments respond faster than areas. It's so close. Check with the light fragments, if someone can get past the light curve, can't prove that they're past the light curve, so now you have that either more light curves or an additional sensor of skating to determine if someone got beyond it in this instance. Or pressure. Yeah.
Okay, thank you.
So, I don't know if I answered that question completely. There are standards and it is all based on speed and what the scan time is of the device that you produce.
There's a factory component that actually. Part line when I most concerned.
Most common collaborative applications that we see, I mean, palletizing is obviously a a very common, very frequent use case. The beauty that I see of a power and force limited palletizer is low rates, scenarios where you may be able to have the robot and a pallet locator on a device that can be either picked up with the fork truck and moved from line to line, depending on, a lot of these food producers are doing, lower case rate volumes, but they might have 8 lines and they may not all be running at the same time. So to do a conveyor system and a traditional industrial robot solution where you're feeding all those lines into like a common 4-in, 4L palletizer or whatever the case may be, it gets really expensive. Slow rate, put the robot one pallet, and then you can move that thing from line to line. So there's a lot of technology that's been released since cobots have come out for ease of programming, pallet pattern generation. You can upload in pallet patterns from other third-party software, stuff like that. But this is a very common application. Another scenario where for a long time in the industry, there's been what I would call non-PFL collaborative applications where industrial robots using area scanners and light curtains don't have a full, complete safety solution, right? Because the fork truck, they want to be able to drive in without getting off and opening a gate. Ultimately, that's a form of collaborative application. It's just not power and force limiting. So, I mean, I don't even know that I need to play it, but there is a video here. So in this scenario, let's see if it plays. Well, I'm not going to play it. Interesting. It played without presenter mode, but whatever.
Really great advertising demo out there with HC, and
Yes.
be sure to check that one out.
Yeah. The one thing that I was going to point out, like from a case rate perspective, if you're doing a single pick, you're going to be somewhere in that 5 to 10 max for a true PFL type cobot palletizing application. If you can do multiple picks, you can, obviously increase that number, but single pick, single place, simple type applications, you're going to be in that 5 to 10 picks per minute. Right? Oh,
I was gonna say, it might be when you do the next slide, because they usually just preload and then it launches.
pretty boring. Simple palletizing. Doesn't get much simpler for a robot, but you'd be amazed how many places you go into and they'll have people stand on the end of a line stacking boxes. So a solution like this, I mean, if you think, just round numbers, big round numbers, that's a $100,000 robot, some conveyor, some controls, base level. Pretty easy to justify that. There shouldn't really be people stacking boxes at the end of lines, whether it's this or a more industrial solution. Collaborative welding. I struggle to even put this slide up here because I don't personally feel like there's anything collaborative about welding. There's really no need for an operator to be in the same space as the robot while he's welding. You can't adjust the motion profile while it's in a weld. Well, you might be able to try, but you're not going to get good results. But we see it all over the place. And it all, in my opinion, comes back to this ease of use. I think there might be one use case that I personally can get behind. And again, I'm injecting my opinion, but if anybody's got other examples, I'm here, I'm interested in listening, but we have a customer that does a lot of big weldments and they do hard surfacing. So if you know anything about welding and hard surfacing, it's literally you take a section and you're just laying weld bead next to it, and it's creating a surface that's more, it's a wear layer essentially. The part is so large, the positioner required to move it around in front of the robot would be very expensive and cumbersome. So they take a cobot on a mobile cart, they wheel it up and they dock it in front of the part and they teach it a little rectangle and it just welds for half hour and just lays bead after bead after bead right alongside each other. That's about the only use case that I've really found where it truly makes sense to be what I would call PFL collaborative for welding. But again, as I said, they're out there all over the place, so it's a subjective. Well, another video for you. So here you'll see an example of hand guiding. So you see the buttons on the wrist of the robot. So he hits one button, he grabs the arm, he drives it into place, he hits another button that is actually teaching that position. So he goes through, teaches a sequence of welds, and then he can put it into play mode, turn on the servos, hit go, and then it welded the path that he taught it. I challenge that anybody that's had a day's worth of time on a teach pendant could program that with the pendant in the same or less time than it took him to physically drag it around. It's just you get used to it. It's like I said, I sold multiple systems where people paid extra to get hand guiding on an industrial robot, and they used it for about 2 months, and then they wanted it taken off because they didn't use it anymore. So whether it's valuable, that's up to you. Machine tending, great application for a cobot. You can have the robot in front of the machine. You can wheel it out of the way, eliminate a lot of the safeguarding. A lot of times, if you're not making super high volume, well, let me back up. Here's a great example of a good opportunity to use a cobot on a machine tool. You have a high volume job that, well, no, let's back up. You have a lot of low volume work, onesie twosie parts that you need that machine to make during the day. So your operator, your machinist, true machinist, right? He's setting up the machine, he's running parts, small batch sizes. He's going to have to be in front of that machine quite a bit because it's not a production, not making tens or thousands of parts, right? However, you may have that one part number that you do have to make high volume. So set that machine up at the end of the day, put the robot in front of the machine at the end of the day, and let it run through the night, potentially. So that would be, in my opinion, a good use case. Yep. Put it on a mobile cart, dock it up to the machine, use it when you want it, use it, move it out of the machine, out of the way, so a machinist can make parts during the day. This one's sped up a little bit. This one's using some vision, pull parts out of the tote. I would most likely have a dual gripper on there so I could pick one and place one while I'm in the machine instead of having to, was in the machining space, that door open time is costing me money. So I would go in, unload, load, and do all that finding of the next part while the machine's cycling. But I didn't make that video, so. I'll talk just a little bit more about our HC series, and then I've got some other videos. I liked a little more interaction. It's gone a little faster than I expected here, but I talked about PFL and FSU. Back to your question of all the safety ratings, how do you know stop state monitoring? We go through what we call type testing, where all of this compliance with all these different regulations and requirements is all done before it is a released product from us. So these arms are running for millions of cycles with weight on them, doing stops and starts, tracking with O-scopes on them. All this is done, not every robot that leaves, but when we release a new product, we go through that entire process to validate that it is consistent, good before it leaves our facility. So once we do that type testing, then we have a standard to work towards. But you can get food grade grease, IP67, I mentioned that. The ISO 10218, which is the kind of the standard. So here's another technology going back to that ease of use. I said that kind of has launched the cobot space. That must be the door. It's all right.
Right, I just kind of like pounded my head at the same time.
It's all good. I'm like, it can't be me because it's up there. Because I'm a fidget, but anyway. One thing that the Cobot and the HC series brought to the Yaskawa lineup is what we call the smart pendant. So our historical teach pendant has got a bunch of tactile physical buttons on the bottom of the pendant, a dead man switch, an e-stop, just like all robots have had for 30 years, 40 or whatever. The advancements in the more tablet-like pendants and the ease of use have really come into play. We took it one step further and we patented a technology we call smart frame. So if anyone's programmed a robot, you know what this is, right? Your right hand rule, XYZ, pitch and roll. And if you've ever programmed a cell where there's maybe some things in goofy angles, you're leaned in, you're trying to figure out, am I going positive, negative, what direction is going to drive me into the part? How am I going to? Everyone's done it. Everyone's crashed a robot because of it, because you just did one of those things. The smart frame does is the pendant is actually calibrated to the base of the robot. So I walk up to the robot is here on the table, I stand in front of it, I hold the pendant flat and in front of it, and I say calibrate. Now that robot controller knows where the pendant is in relation to the base of the robot. So if I'm still standing here and I tell it to go right, it goes right. If I come over here and I say go right, it goes right. Doesn't matter where I am. There's a button on there where I can have it work in tool mode and I can hold my finger on the button, I can tilt the pendant and I can make it rotate about a circle. So there's basically sensor technology built into the actual pendant itself that allows you to manipulate the robot in a more simplistic method rather than am I in tool frame or am I in world frame or am I in some special user coordinate system? It's real easy. You can still have all those. You don't lose the functionality of reference frames or any of that. It's all there. But if you want the simplified method, you have it. I'm gonna jump out of my Prezo for a second here. There's some brands on here that aren't here today, and I'm not trying to get sideways or any idea why it wouldn't be sharing? There we go. So these happen to be brand X Power and Force Limited robots. And I look at that and I say, what the heck? Why would you ever do that with that robot? It's obviously doing the job. So I can't say it's wrong, but I can promise you that there's an industrial robot and it doesn't have to be ours. It could be any other industrial brand out there that could likely do that job and would challenge probably not any more difficult to program. There's a lot of stuff going on. So would anybody in this room put a cobot in that application?
I noticed one, but again, for maybe a lot of smaller businesses.
Yep.
They plug into a 120-volt outlet,
Yep.
whereas a lot of industrial robots do not.
That is a very good point, and it's a
I know
valid.
a lot of industrial robots could power 40 single phase, but some of these customers that are buying them might not be electricians, but like you said, because programming interface is easy, they're able to plug that into the wall and get that going.
Yep.
Probably not a fixture.
Right. Right. That's an interesting one. Anyway, I caught that on LinkedIn the other day, and I just knowing that I was going to give this presentation or this discussion, I'm like, I'm going to save that one and come back to it because again, it's obviously not wrong. It's working. Having been in the industry before cobots were a thing, I would have never thought to use a power and force limited robot for that application. Because there's at no point do you see any interaction with any person. And I can promise you that I could have sold industrial robots at a lower cost than what those were. But there's probably a familiarity with the programming style or the language or whatever the case may be. So I got another one here. This is another. So this is an example of something that, again, they're not here. Nobody's offering this today. It's just to kind of get the thought process going. This particular weld cell is fully safeguarded. It has automatic doors opening and closing. There's really no interaction with the person while the robot's welding. In my professional opinion, I don't care what brand industrial robot, it's more the longevity of an industrial robot in a welding application is much greater than an industrial robot. There's plastic on the wrists of that robot that is not going to survive long term in welding environment. So I know for a fact that this system, because I actually had a customer that's not too far away from here buy one, and it's over $200,000. And the system that's right outside the door here is very similar. It's got sliding gates, but it's an industrial robot. Got all the similar ease of use programming tools, and it's significantly less. Significantly less. So, sort of thought provoking. I'm not saying, is it wrong? I can't say it's wrong. It'll weld, it works. But as you're looking at potential applications, potential projects, there's always multiple ways to skin the cat. And I guess part of my point that I wanted to make here is challenge whoever, like whether it's internal or a sales guy, get to the what do we really need and what's going to serve us best long term. And it may be a cobot, it may be an industrial robot. The beauty is the lines are getting more and more blurred every day. I wasn't sure if I was going to be able to use my laptop or Mechatronic's laptop, so I made some notes here because I had sent this before I had time to put presenter notes in. So I'm just kind of checking a few things. I guess any thoughts or questions or comments? Am I crazy? Yeah.
A couple months ago, we had another talk from another presenter. And on the note of using collaboratives as machine tending, one of the things that came up was that as it becomes more commoditized, easier to acquire, easier to train, they were speculating that there would kind of always be a floater component, and that different parts of the factory would be able to use it, train it to do this quick thing, return it back when you're done, and that would turn into a futuristic Swiss Army knife, so to speak. You know, swapping out different end of arm tooling, swapping out different applications, saving a lot of reload builds. So that was something where specifically, yeah, like someone over there was mentioning just literally using it for anything between your knees and shoulders, you can lift. Below that and above that, you get a cobot to do it for you instead. That was an application that we kind of see pass through. It was just like, we just don't want anyone to risk their backs.
Yeah.
So that was kind of where it was coming into, but they shared a similar thought of using it in atypical ways that you would think, because you can't have an industrial robot do that. You can't have this be an agile tool for your workforce. That's not, I don't want to share that. I don't know if there's a lot of pushback on that in the room or not.
My opinion is I would agree with that. I think that those are the areas where it probably does make sense to incorporate some PFL level cobots because of the unknown, right? If you've got a dedicated application, you have unknowns. Now it's pretty easy to make a decision as to whether you need PFL or not. But if you're looking for that Swiss Army knife and you don't know what it might be doing a month from now or 6 months from now, to look at that PFL level robot, you're making a little higher investment in the robot itself, but you're giving yourself that flexibility down the road in the future. The idea of moving robots around, though, from my experience, another example, this is 15 years ago, a machine shop, just kind of like what I said earlier about the setting it up to run a high volume run and letting the machinist run low volume parts during the day. This particular client came to us, they had one major part from one major customer, and the volumes didn't justify a full machine and a full robot to be fully utilized. So they contracted us to develop a cart, and this was way before PFL robots. Well, it wasn't way before, but before they were accepted. And so we built the cart, we built the docking station, we made sure everything was calibrated, it all worked, quick disconnects on all the cables, all the connections. He set it up. He invited his customer that he was producing the parts for to come in and look at it. He said, hey, look, I've made this investment in this technology to run your parts. He didn't even realize what the potential was. That customer, before he left that day, doubled the volume. So he had multiple people making that product, but once he saw that part being run on the robot, so he spent all this money to have this docking station, mobile robot, moved out of the way, never used it. It stayed connected to the machine all the time because that particular client had more business for him to put into that machine. So
It's good investment.
fantastic investment. Yes, absolutely. Yep. And that's something that I see a lot, and it has nothing to do with cobot versus industrial, but it has more to do with that dive into automation. So if you're on the fence of, if you're an OEM and you make your own product, you know what you need to make. But if you're any kind of job shop or making product for someone else, finding out what other work might be available that's similar, you make the investment into the automation, then you go find work that matches that or that fits that envelope. And that's where the growth comes. And we always joke about well applied, well implemented automation, doesn't matter what it is, if it's a robot, a gantry, a cobot, will make babies. It will replicate because it just works. It doesn't have, it's not a black science, it's not magic. Do it well, do it right, and you'll have more. Like I said, I've got some other slides, but I don't want to make this a pitch, and we're getting close to our time here anyway. One other thing that I'll mention, I know it's not here, and we're not in an Allen Bradley house, but we know Allen Bradley socially accepted in industry. All of our robots have what we call an MLX option. So you can program the robot in Rockwell, right in the ladder. All the kinematics are still done in the robot controller, but if you've got an Allen Bradley PLC and you want the robot logic to be built into the ladder, we have a tool for that. So for our particular models, we have a 10 kilogram payload, so we don't play in the real small power and force limiting robot space. We have a 10 kilogram model, which you'll see out on the floor. We have a 20 kilogram payload model, which is a little bit longer reach, a little bit bigger mechanical unit. And then we have a 30 kilogram payload, which is exactly the same mechanically as the 20, but we limit the wrist. So I'll use Chad's famous pointer, even though I have this one, I like this one better. So this joint right here, well, and the T-axis, these two joints are, if we want to use the term weakest, I'll use the term weakest. They're the limiting axes for the payload. So what we do to make our 20-kilogram robot a 30-kilogram robot is we limit its range of motion. So that flange, that faceplate has to stay within 15 degrees of it. But allows us to pick up more weight because we're not trying to tip it up and flip it around. Primarily for palletizing. That kind of hits on those products. Any other questions? Nothing, Blake?
The ease of programming and all that, but see that there's no reason you couldn't be bringing that ease of programming to an industrial.
It's coming.
That's
It's already taking place. It's happening. When we released the Smart Pendant, initially, that's the tablet-based pendant that has an HMI capability and it's got a bunch of the ease of use functionality. There was at early release, there was no intention of ever rolling that into our industrial line. Today, it's basically, it's not formally released on every product, but there's no reason why it couldn't be. We have it through all our palletizers, all of our medium payload, general purpose arms. So all the ease of use functionality. And I love that about the market. And again, they're not here and I'm not trying to sell their stuff. I'd actually have worked on it and I don't love it. But UR did a phenomenal job of getting that perception of automation being difficult. They calmed that and it's opened the door in a lot of places. Well, with that, if there's no other questions, I appreciate everybody taking the time. Hopefully it wasn't too boring. And thank you.